So I'm very happy to introduce you to our second speaker, who is Magali Feys. Magali is founder of A Contrario. I hope I pronounced it correctly, Magali. That's a business law firm offering specialized legal advice on IP, IT, and data protection. Magali specializes in all aspects of intellectual property, information technology, and data protection laws, and deals with matters of e-commerce, consumer protection, and unfair market practices. Throughout her career, she has been accumulating a lot of experience in the domain of privacy and data protection. She also co-authored several legislative proposals concerning the GDPR on the Belgium as well as on the European level. And she gives specialized training to become a certified DPO or data protection officer. She was a member of the Commission on e-health of the Cabinet of the Minister for Public Healthcare, Maggie de Blok in Belgium. In other words, Magali is the right speaker to tell us more why we don't have to choose between data privacy and better healthcare. Magali, thank you for joining us. We had a great interview earlier this year, and I'd love to share these insights with the attendees of the webinar. Please go ahead.
Okay, well, thank you, Wim, and thank you for this nice introduction. Hello, everybody, and thank you for having me on this webinar. So I want to talk today about why we don't have to choose between privacy and health. And I'm just gonna, because I only have 20 minutes and I can talk for hours, as it is also my research at University of Ghent, where I do research on the secondary usage or secondary purpose of health data. So I can talk for hours, but I will make sure that I keep within my time limits. And I want to talk today about the fair trade data principles and how we can actually achieve that. And if you allow me, I can share my screen.
Please go ahead.
Thank you. I'll make sure that I have this. Are you seeing? Oh no, are you seeing the screen? Yes, or?
Yes, we can see it.
Sorry. And then I'm gonna just put it in presentation mode, if that is okay.
Yes.
There we go. So first of all, I know COVID-19 has brought a lot of negative effects, but I definitely wanted to state at least one positive effect in this very enduring times for everybody is the fact that because of this crisis, we have really seen a rise in digital health. And there was a demand for health data, and it really increased. And we also saw that really digital health also and the different solutions increased because, as also mentioned by the previous speaker, we really needed to share data. We also worked on a collaborative research project where CT scans needed to be shared in order to train an algorithm in order to rapidly be able to diagnose COVID and the status thereof. So that actually took a really wonderful project that is still in the running as the algorithms are trained and are really also put into the market. But we also saw that, of course, there was an increase in the use of AI and different technologies. And there then also came the question, how do we treat privacy and how do we deal with privacy? And there was, and although the great respect for Yuval Noah Harari, he stated in an article in the Financial Times, in March 2020, that when people had to choose between health and privacy, that they would actually always choose their health and do not care about privacy. And although I think that might be an accurate statement, I do not believe that we have to make that binary choice and that we can balance both choices towards each other. I don't think it is always a matter of a possibility of really having a 50-50 balance, but there is definitely a way of balancing it, where you will then also see, and I will come back on that, that you can actually maximize data utility And so on the one hand, protecting privacy. I think we should also see it more elaborately in the fact that it's not only about privacy, because we know that indeed sometimes patient people do not care that much about their privacy, but I think it's much more a tale of trust creation, a trust creation towards patients, a trust creation if you are a software provider, or towards the healthcare professionals and the hospitals, so that they can rely on your systems. We also saw that, as also mentioned by Frank, for example, with the cloud, there was a big fear that it was not secure enough. There is really a fear when hospitals are engaging software providers. Is it secure enough? So when we really take that into consideration and we really balance data protection, privacy, against also the fact that it can really be data utility, I think this is a success story. Also, and if definitely with regard to AI, there are also other concerns, not only the data protection ones, but there is also the fact that an algorithm is only as good as the data that is fed into the algorithm. And if we would feed the algorithm with incorrect data or incomplete data, and we see sometimes, and there's why I'm also doing my research on that. For example, a lot of people talk about, oh, we're going to anonymize the data and then we're going to train the algorithm, because anonymized data falls outside the scope of the GDPR, of most data protection regulations. And so we can definitely use and share it without limits, without borders. But we see that that actually is only a little amount of data that you can share, because a lot of people do not consider use case specific anonymization, and we will also see why it will also not work, and that it has some ethical boundaries too. With synthetic data, and I know there are really very scientific good solutions on the market, so I don't want to all throw them in the water, but they're all based on two principles. Is first that they will translate the data, and there will already be a choice of data that will be used in order to create a scientific data. And so I'm always wondering then, how are there no underlying correlations that you might not have taken into consideration? And by already taking them out or not taking them into consideration in the scientific data, are you already not creating maybe incomplete data as such? And secondly, synthetic data is mostly based also on the fact that then the raw data is thrown away, so that it is also, once again, anonymized data. And also there we will see that there are some ethical, or there might be ethical questions around that. So we can all agree that, of course, those feeding algorithms with that type of data could have, I'm not saying by definition, but could have huge consequences. And it was not in the medical world, but I think there are two examples that shows that if you do not think about some correlations in your data, that we saw that, for example, with regard to parole decisions, we see, for example, that and the American system was considered racist, not that the algorithm all of a sudden was racist, not that the data scientists were racist, but because they didn't consider the historical facts in the data, and that there was a correlation with race and historical sentences. And you see here in the example that, for example, somebody from an Afro-American ethnicity or background who had actually committed less defenses had more risk, just actually based on their race rather than actually on the offenses itself. And we also had another example when a husky was confused with a wolf. So they trained an algorithm to see whether the picture was a picture of a wolf and whether the picture was a picture of a husky. And so you see in 5 of the 6 times the algorithm was correct, but in at the bottom of the page in the left corner, the algorithm got it wrong. And so why was that? In left, you see the original picture, I'm sorry. And on the right side, you see the picture of what the algorithm was actually interpreting. And the algorithm also seeks the easiest way out, because it's an algorithm, it's mathematics. And so you see, it doesn't take actually the wolf or the animal itself in consideration, but it took whether they were snow or not, because they fed the algorithm with a lot of images of wolves, but the wolves were always depicted with snow, and huskies were most of the time, being domestic animals, mostly depicted without snow. So the algorithm thought for itself, okay, snow, wolf, no snow, husky. And so with this, which was a husky, but in the snow, the algorithm got it wrong. So then we want to talk about fair trade data, because I think it's very important that we can use our data, and we get from health systems a lot of data that we use from our primary purposes in order really to treat patients. I think already in the collection of the data, it is really good to think about what we want to do with the data and set up a data management plan, but I will come back to that. But once we have that data, and let's be honest, a lot of hospitals, research institutions in the world really are sitting on a big pile of data, which are really the new gold in order to create AI, in order to do further research. And it is absolutely important to have that data being transferred and leaving, as Frank already said, there must be leaving, the data must leave the building, but to do that in a good way. And so it is really important to consume data in a way that it is ethical, that it's not harm individuals, because we are really talking about patients and their health data, and that this is something that we consider not only at the collection of the data, because that is something we've seen with GDPR and clinical trials, that at the time of the data, there is people are really complying with GDPR, with the legal grounds, with all the steps of GDPR. But then once the data is in the hospital or within the research institution and it needs to be further used, that some of the basic principles are left behind and not taken into consideration. So it is very important to really have that along the chain. And fair trade data really goes about the fact that technical safeguards must be embodied and embedded in fair trade data in order to maintain fidelity and to reduce the possibility of re-identification or control re-identification. We will come back to that, to reduce the possibility of bias and discrimination, but at the same time, make sure that we maintain the highest level of trust in the observation and decision-making that results from its use. Now, we've put fair trade data versus conflict data, a little analogy with conflict diamonds being used against a country in which they were illegally mined to the disadvantage of that country. Fair trade data really refers to data that has embedded, technically enforced, granularly privacy controls to eliminate the risk of conflict data. And what is conflict data? Well, that is data that contains the risk that personal information is being used in the disadvantage, and what that disadvantage that can be interpreted really broadly, but against the disadvantage of a certain person. So what are those fair trade data principles? Well, first, before I talk about the 7 fair trade data principles, I want to talk about the fact that GDPR also has what we call 10 cornerstones. We divided them in 10 cornerstones. And I think a good GDPR exercise really needs you to have a 316 approach to really walk and be able to check all those cornerstones. But I know that GDPR is often stated, it's a little bit what Harari also referred to in his article. It's GDPR versus innovation, and a GDPR that goes against innovation. But I don't think that is the case. And I really want to explain that actually by taking into account a number of those GDPR obligations, we can really, on the one hand, create that trust and embody that trust and ethic data management, and on the other hand, maximize data utility. I also want to state that GDPR should not be done or GDPR compliance only in order to avoid the penalties. Of course, that is a big incentive. We can all agree, but that should be actually some collateral advantage you tackle along with a GDPR compliance, because if GDPR compliance is also dealt in a good way, and you start from a data management protection plan, a data management protection strategy, where you actually also map your data flows, you will have also the capabilities of better protecting your data. And we talked about cybersecurity, and we know that cybercrime is on the rise. So by actually knowing where your data is, knowing where your data flows, will help you in order to really more secure your data. And that is, so it is really also what we want to embody with the fair trade data principles, is a 360-degree approach. Not only that you look at it from a legal perspective, not only that you look at it from an ethical perspective, but that it is really putting that it is as important to have, on the one hand, ethical and legal principles, but that also translate them in technical and organizational controls and safeguards. Now, in order, you have to have a data management plan. You have to know what you want to do with your data. You have to review your data management plan at a regular basis. And that will also help you to structure and label the data, because there is, everybody always talks about GDPR, but there are still also intellectual property rights. There could also be contractual obligations that are applicable on the data. So structuring and labeling the data, I think, is the first step of being able to handle your data correctly and actually have fair trade data where you can maximize the utility. Because otherwise, if you don't have that plan, it really becomes difficult to then make sure that you can protect and make sure that you have fair trade data. Then it is one of the keystones of GDPR, but we see it often forgotten or often very badly translated into practice, but it is data protection by design and by default. And what is that actually? It is translating the legal and ethical GDPR requirements into technical controls. And it is very important that the protections can be embedded into the data to reduce re-identification, because it is all about data minimization. But we will see that that doesn't always mean on the quantity of the data, but that it is really with regards to putting necessary controls. And we will see that one of the best concepts in order to do that, that is GDPR compliant pseudonymization. And that will actually enable a lot of research institutions, hospitals, in order to authorize them to use the data for further data usage. Okay, then we have technical and organizational safeguards that are required for data and advanced processing to be legal. First, and that is also something we see, we have had historical data. Sometimes it was non-compliant because we didn't think about asking for consent, or we didn't think about what was the legal basis. So it is very important to do the exercise and to transform non-compliance GDPR data into compliant data, so that that you can really use that data for further purposes. And so you also need to think about the lawful basis, because otherwise you will tag along what we call conflicted data or contaminated data. Problem is also when you share that data, you also will put the burden of responsibility really on the other institution, and they could also be held liable. We have seen that with the decision of the Dutch supervisory authority, so that actually within the chain of different controllers, that is really put further in the chain, and that every player was then held responsible because of the fact that the data was not compliant and thus contaminated. Data use minimization is also very important. It is by dynamically controlling re-identification, by dynamically also reducing re-identification risks, maximize authorized uses of data, and thus minimize unauthorized uses of data. Then it's also about transparency and audit controls, and transparency is also very important. And once again, it is not about the transparency at the moment of collection of the data, but it is also really in the further process, the further data life as such, and also data audit controls. So you really have to enable the availability of statistical properties of data sets. And you really have to use policies and notices in order to keep that data. Then there is also the fact that you have to, if that data is shared, that also that policy enforcement is cross-shared and also embedded and enforced throughout the different entities the data is shared with, and also that you have a possibility to think about real-time policy adjustment. Those are the 7 principles of fair trade data. Now, if we look at data protection by design and GDPR compliant pseudonymization, we know that there are a lot of misunderstandings about that, because we have seen, and that also makes sure that then the data is conflicted, because given that there is a re-identification risk that is not controlled, and so that everybody could re-identify the data and actually identify the individual, and thus share data that is not enough protected. We have seen that is something that really happens a lot. Why is that? Because a lot of people think that pseudonymized data, anonymized data, that it is enough to actually delete the direct identifiers. Now, what are direct identifiers? That is the name, the national security number. It could also be another specific token. We also have indirect identifiers like gender, birth date, university degree, but also indirect identifiers could also be a pathology, could also be a date you were taken into the hospital or the patient was treated, could also be a drug scheme. So we also put IP addresses here, but so there is a lot of data points that actually are also indirect identifiers. And you can imagine if you only delete the direct identifiers, but you still have, for example, gender, birth date, you still have at the same time a pathology, type of, for example, it's somebody with cancer, type of cancer, which doctor is treating the patient, on which date the patient was admitted to the hospital, and things like that, then you can actually really easily re-identify the person. So actually working with pseudonymized data has really extreme benefits and can really augment the data utility, but we really have to think about of doing it right and doing it use case by use case basis. Because what is anonymized or anonymous data versus pseudonymized data? And so the GDPR actually does not provide for a definition of anonymous data. Also, for your understanding, it also becomes more complicated because in a number of jurisdictions throughout the world, anonymization is used when they want to mean pseudonymization. Sometimes de-identification is used. We used to use in the European Union functional separation, but then they changed it into pseudonymization. So what is anonymous or anonymized data? That is data that is not reasonably possible to link it to the data to the data subject. And that is by using direct or indirect identifiers. So let's be very careful, because as I already stated, it is the fact that mere coding or leaving out certain direct identifiers is in most of the time, and the more data points you have, it is definitely not enough to talk about anonymized data. Now, what is personal data, anonymized versus pseudonymized data? Well, pseudonymized data is actually the same, has the same outcome of anonymized data. And so I will start with saying it is not failed anonymization, because we have seen in practice that a lot of people think, oh, you have anonymization, which is like the highest step. And whatever we do underneath that, which is not anonymization, well, we just call it pseudonymization. I will show you with a very clear example that that is definitely not the case. That is not the definition of GDPR compliant pseudonymization as written in the GDPR. So what is pseudonymized data? There is an entire definition, but let me explain it with a more ideal graphic for that. It is really separating the identity from the information value, because you need the information value. You need that data in order to do, for example, further research, in order to do AI or algorithmic training. So that information value, that is really what you want, but you really do not want always that identity. So you separate both, and you make sure, if we see it here with this graphic, that the identity is separated from the information value. And so there's a wall, and there is no way you can jump over the wall. The only way you can go back to the identity is by using additional information. Now, a lot of people think that that additional information is the data that was deleted, so that you keep a part of that data set, and that is the additional information. No, I consider, but that's my way of making it more easy understandable, that additional information is your toolbox. It are your keys, your tokens. It are the different privacy enhancement techniques in order to separate identity from information value and be able to link it as such. Now, you really get information value, and that data set is equal to anonymized data, because based on that data set, you cannot, if you would only have that information value data set, you would not be able to go back to the identity of the data of the person. Only way of doing that is of going to use your toolbox, and then you can actually relink it. But they say it's a sort of controlled relinkage, because the access to that additional information must really be protected and can only be given to a number of persons. So the fact is, the information value, the data set you create, is what I call local anonymized data. The difference with anonymized data is that you still have the way of actually going back to the data subject in a controlled way. And that is very good, because give us this example. Let's say that we actually made sure that from a patient, we got, when he came into the hospital, he got a treatment. So he or she did not have to give any consent. There was a treatment exemption, and you further on, you take the 360-degree approach of the GDPR. You think about transparency, you think about data minimization, and you say, okay, we're gonna anonymize that data because we're gonna train our algorithm, but we're really gonna use that data. And let's say that all of a sudden, and you anonymize the data, that means that you throw away the additional information and the identity. And all of a sudden, John Jeffries comes knocking on your door of the hospital or research institution and says, well, look, I saw, because you were very transparent, that you want to use my data to train an algorithm. But I, from an ethical perspective, I do not believe in AI, and I do not want that my data, even if my privacy is protected or not, but from my ethical point of view, I do not want my data to be used in order to train AI, because I'm against AI. I think that is the freedom of speech. That is the fact that people are allowed to think that. The problem is, if we work with anonymized data, there is no way of going back and knowing who was John Jeffries, and you just already used his information value, and you're actually going to use that. So there is no way of going back and saying, okay, John Jeffries, you can actually exercise your right not to want to be included in an AI research project. Whilst, for example, if you work with pseudonymized data, you have that information value, but the fact that you can do a controlled relinking will enable you to actually see, well, there could also then be other constraints, but at least you still have the technical possibility to exercise John's rights and to say, okay, we then going to take your data out of the data set. Just an example to show you the difference between slightly minimized data, further minimized data, and pseudonymized data. So here it is an example from HR perspective, but I think it really shows you the way of how we have to start thinking about truly pseudonymized data. And so the first one is, of course, the raw data set. Slightly minimized is where they took away some of the data. Further minimized is where they replaced the direct identifiers with tokens. But you can still think, for example, if this was a company in Zurich where only 5 women work in IT, and there is only 2 women who have actually gained that wage and meet or exceed the standards, yeah, then it's very easy to go back and to say, okay, apparently this data set is about Mary Jeffries. So we really see that then in the variant tree, you really have pseudonymized data, because but you have to make sure it's always use case by use case. If, for example, the company only have 1 office in Switzerland and they're only working 4 people, and there is only 1 app developer, once again, that example would not be pseudonymized data, but you see it is really a high standard. And we have also seen that because a lot of for me, it is really a mathematical sort of a decision that needs to be taken. And you have to make sure that in the use case you want to use it with all the data sets, that the data, that the information value you want to get, that information value is really not possible to re-identify the data subject. And so it's a case by case. And of course, if you only have a couple of data points, the exercise is quite easy, but the more data points you have, and let's all agree, for AI training, we already saw that accurate data is really important. And the more data you have, the more you can also see which correlations actually can then influence also the decision. Now, we also see that if you only work with static identifiers, that will also not help, because there was a study, the Mosaic Effect study from Harvard University, where they actually created 3 different data sets based on the birth date. So that was the only data point. There was then a data set based on gender. So you had the gender, and a data set based on the zip code. But they used static tokens, which meant actually that you would have a data set where you had ABCD with this birth date, then a data set with ABCD with this zip code, and ABCD had the gender was male. Well, actually, then it is very easy in order to start combining those 3 data sets and say, oh, but we see 3 times ABC3. So ABC3 has that birth date, has that zip code, and is a male. And then given that, of course, this is an example outside the health data, but they start looking at Facebook and other data that is available, and they were actually able to re-identify 87% of US citizens. So just by 3 parameters. So there are a lot of people who say to me, oh, we anonymized the data because we only have 3 parameters. Well, you see, there was an example, a study that actually showed that that was not correct. Now, how does that come? That is because they used static tokens. So one of the first things is really, and that is one of the fair trade data principles, is really use dynamic de-identification, dynamic tokens, because if you, in every data set, you really change the tokens, and you have, for example, it's always Alex Smith, but in the one data set, he's ABCD, in the other one, he's Q9 and what so, and in the other one is 19 and something else. You can, of course, see that there will not, even if you then have those 3 data sets, you have no possibility anymore to really combine and know that ABCD, Q9 and 19 are really the same person. The only one who can do that and do that re-identification, and thus can come up to the fact that behind those 3 tokens, there is always Alex Smith. That is the one who keeps the keys to the toolbox, to the additional information. Now, a very important slide, because I use it as an analogy, because we have seen that a lot of people think then, okay, because if we want to then pseudonymize data, you really have to do it use case specific. And let me explain you why it has its potential and its advantages over anonymization. Anonymization would really mean that if you do it once, you really throw away that toolbox. So you cannot go back to the data as such, the raw data, because if you keep the raw data, you cannot state that you anonymize the data. It is stated once again by, for example, the European Data Protection Board, that if the controller keeps the raw data and is possible to re-identify the data, that we cannot speak about anonymization. So anonymization is a one-way trajectory and really a one-way trip. So once you anonymize the data, you have thrown away all the data. So your useful information, a lot of useful information value, and you will only be able to use it for one use case specific. Now, what is pseudonymization? It really helps you to do it in a use case specific manner. So you create a data warehouse or a data lake, and every time there comes a use case, you really think, okay, how can we pseudonymize the data? And I actually use the analogy of the water tap, and it's depicted here. We used to use data for data transfer without thinking. It was like where we were brushing our teeth, we let the water run. And then afterwards, if we said, well, how many water did we actually use? How much did we actually need it for that data project or for that project? We would actually not be able to say, because it just ran and we had no controls over it whatsoever. Now, what is anonymization and pseudonymization is putting the tap, close it whilst brushing the teeth, and thus putting a control. The problem is with anonymization that it would mean that you open the water tap and that you only get 3 drops of water, because that was your anonymization process. Now, let's say that you are with 4 in the bathroom and you you used a very bad tasting toothpaste. You're with 4 in the bathroom and you want to wash your mouth. Yeah, the 3 drops will definitely not be sufficient. And there you're standing. So for example, if we translate it back to data, you have anonymized data, but you might not have enough data to really use for AI. And the problem is you cannot go back, because there is no way of going back anymore. Now with pseudonymized data, you open the tap and you say, well, for this, for example, today I'm alone and I used the good tasting toothbrush. So I need the 4 drops. And for example, those 4 drops can be enough, or this little sip of water is enough to wash my mouth. But let's say we're here with 4 in the bathroom. We use the bad tasting toothpaste. So we need actually a use case for the big glass of water. That is actually still possible. Now, the thing is, of course, that is, for example, when you do AI training, when you do a number of business analytics. Now, of course, you've seen in my example, and I go back with Mary Jeffries, that at a certain point, also using dynamic de-identifiers, you will not be able to see the raw data anymore. But that is not a problem. It is true that for us, that data would probably not mean a lot, but for the computer, honestly, if you train AI, if you feed that computer with English, or you would feed it with only these type of tokens, that for the computer, it can read it and it can train its algorithm. And so you see, you can really use all your data. But on the one hand, so you really have accurate data, because if pseudonymization is used in a good and GDPR compliant way, we have seen that we can maintain 100% accuracy rate. So you really can use all your data in order to train the algorithm or your whatever use case possibilities, and so maximize your data utility. But on the other hand, you're protecting the data subject's privacy because his identity is separated. And on the other hand, you're also doing it in an ethical way because of the controlled re-identification. You can go back and you can always exercise certain patient rights if you want to exercise them, but there is no more risk of uncontrolled re-identification because of the fact that your toolbox is really kept separately. But once again, it really needs a fact that you really have to know your data flows. You really have to invest in actually structuring, labeling the data, making sure when it comes in the data lake that you then, once you need it in your use case specific use cases and opportunities, you can really implement GDPR compliant pseudonymization. And I do understand that really is, and it asks for quite the investment, but it really pays off because at that point you will actually be able to use the data where if today you're doing it, well, or you're doing it and you're using contaminated data if you're misusing or it's not proper used pseudonymized or anonymized data. And you're also contaminating the other parties with who you're sharing the data. And probably the contracts have clauses in them that they can come back towards you with big liability amounts. There's then also the penalty amounts. So you see, that is definitely not a comfortable situation to be in. Or if you say, oh, we don't have those controls in place, well, it will actually make enable you not, or you're not able to actually use that data. So it definitely is worth the while. Due to controlled re-identification, you also can thus maximize privacy, build trust, actually make sure, because it is a way of showing that you have the necessary technical controls and organizational controls in place, that you are GDPR compliant, and on the other hand, really maximize your data utility. So that's how you can actually balance those two, and that it should not be a binary choice. Thank you. Sorry, Wim, you're on mute.
No, it's good to come again. Sorry. So I have one question for you. If we look now at who is controlling data, right? So in hospitals and so on, it's usually controlled by hospitals or by clinicians and so on. So they are in control, let's say, of your data, of your health data. Mm-hmm. There is a kind of movement in the direction of the democratization of the use of data by patients and so on, and digitalization may help in that. How can your story help in doing this? How much is pseudonymization necessary to go in that direction?
Well, I think it definitely helps in the fact that I think it really is about protecting the rights of the data subject. But it is definitely, and it's definitely a protection and safeguards towards that secondary use, where you really want to use the data for further scientific research. If you have done a clinical trial or you have done a treatment, you have that big pile of data and you want to use it. But also, given that you build in those controls, so it's not only a story of putting pseudonymization. It's what I call with the 7 principles. You structure and you label the data. By labeling the data, that would also mean, for example, let's say I'm a patient. I went with my doctor to the hospital. I got a treatment. But for example, and then my data is being used in a scientific research. And let's say they don't need consent because it's not a clinical trial or whatever. Then, for example, if it's labeled, it could, if it would be a digital managed system, the patient could get a notification saying, oh, Magali, just know your data is now also used. You can really, you make it into a nice story. I think that is very important. You say, look, your data, you now contribute to further research because we will use your data in a really secure way, because and then you can explain, I think, of course, in a very not too difficult way, but it really, I think, enhances the whole process of structuring, labeling the data, really knowing where your data is, securing the data, and then having the controls in order to further share the data. So it is really throughout the life cycle of that data, you can come back to the patient and actually give him or her more information. And we have already seen that if people are given more information and say, can we use your data for this and this? Actually, or you inform them and they say, oh, that's good. But what is actually going now against the fact that they are sharing the data is the fact of the unknown, what is happening with the data. And definitely when it's with regard to their health data, because of course, nobody wants that if there is no a medical or legal reason to share your data, for example, with an insurance company, that their data all of a sudden would be used with an insurance practice, going back and say, oh, Magali, you paid us this amount, but next year it's going to be up because we saw you had this and this. So that is that trust building. And I think transparency, which is one of the keystones of GDPR, is really helping in that. And that is one of the principles. By actually putting it in a sort of data management system, you're really endorsing that, and you're creating further that trust. And also because it is always a chain on chain reaction, because given the fact that you are then able to work with a lot of data, accurate data, you have less bias. People will trust AI more if we have, of course, ethical AI, but you have put that in the system because you work with fair trade data. So it is something that actually will come back, and that will make the circle or the vicious circle going further, and the chain going more rapidly once installed.
Good. Ijeoma, I think there are questions from the attendees.
Yes, thank you, Professor Wim. Thank you, Magali. I found your presentation very, very interesting.
Thank you.
We have a question from Yoo Jung Ha. He wants to know if pseudonymization technique is patentable. In the presentation, I think you briefly mentioned this. Thank you for your insightful presentation. That's from Yoo Jung Ha.
I definitely think it's patentable, because I also, we work for one of our clients has a pseudonymization tool. There are different pseudonymization tools, because I think we also worked in the example I give, imaging COVID AI, where an AI algorithm was created in order to diagnose COVID based on a CT scan. There it was most of the times based on medical images, and the pseudonymization pseudonymization technique was by a Spanish company patented. The company, the other American company we are working for, also has several patents in order to have that pseudonymization technique and software patented. And there is also not one way. That's why I said it's really a use case, because it's a mathematical decision and you have to take into consideration a number of parameters. But it is definitely patentable, because it's also a solution, because it's if you work with a lot of data points. For example, if you want to create a micro segment, let's say that and it's not a healthcare example, but we have it Nike in the online advertising. Probably you know or you don't know, but there is a lot of online bidding always done. And today they do it, and that is the big problem with the Googles and everything of the world. They don't do it on the right ethical principles. They bid constantly on your entire profile. Whilst, for example, let's say that Nike has a new sportwear for women, and they say, oh, we know it's going to be women that have, because of the colors, I'm just saying, between that age and that age, we know that our target group are going to be women that don't sport a lot or sport a lot, whatever is the target group. If you then, of course, create micro segments, those micro segments can be quite easily, and that's also pseudonymization, that's so that you keep the data, you separate the information value, you give in a controlled way to Nike, and you say, look, okay, this is the micro segment you want to bid on. And then there is a trusted party who has the additional information. And for example, that knows that Nike has to send Ijeoma to you an advertisement, and maybe not to me or the other way around, but they still get money for what they bought. But our data is preserved and our privacy is preserved. And I think that will lead to much more trust creation in, once again, also that whole cycle. So it is, and so if you don't have a lot of data points, it's an easy exercise, but the more data points, the more difficult data points like medical images you have, the more difficult, of course, the exercise is, and therefore a solution is needed. And of course, that is R&D. And I always, as an intellectual property lawyer, I also believe that that should be protected.
Okay, we have another question from Ida Wolf. The question is, the Working Party 29 is very clear regarding pseudonymization and anonymization, including the risk of singling out. And I think he noted here that anonymization needs consent, since it is also processing of data. Mm-hmm. And I think he just wants to get an insight on that.
That is true. So a lot of people think, and that is what I see is for me the biggest problem with, well, the two biggest problems. I think you throw away data, and as data is the new gold, you're throwing away data utility possibilities. The second thing is indeed a lot of companies or parties forget that anonymization is a processing activity, and thus you need a legal basis. The question is it always consent? There are other legal bases. But that is definitely to think about. I do know about all. I had a slide with regard to Schrems too, but I didn't want to overload you all with actually their different opinions of the European Data Protection Board and European Data Protection Supervisor. And the recommendation the person is referring to is a pre-GDPR recommendation, which means that the pre-GDPR concept of pseudonymization is used, where indeed there it was most of the time used as a sort of only taking away the direct identifiers. And therefore, because we have talked with the European Data Protection Board, because we also filed a memorandum with Schrems 2 and our use case too, pseudonymization or the use of pseudonymized data is actually seen as a safeguard, an additional safeguard that is adequate under Schrems 2 judgment. And so we talked with them, and we really had a great insight on the discussion also in GDPR, why they raised the bar for pseudonymization, because indeed using a pseudonym like we do it in literature, that indeed doesn't help. That is not as I explained, an adequate control, because the risk of re-identification is, I think, in 95 of the cases way too high, or really potential, where the new GDPR defined or compliant pseudonymization is, as I said, raising the bar, and it's a whole other level you have to comply with, and therefore it does work.
We have to finish because we are going over time, but let me give you the last question from Abbas Namdar. Is labeling in anonymizations the same as labeling in classification techniques?
Well, it could be the same. I'm of course not a data scientist, so I'm going to be careful with this. I think it's an additional for me it's an additional layer, because it really goes with regards to IP rights. It goes with regards to also labeling it with regards to data subject rights. If, for example, your data subject has given, and when you use, we also are advising a lot of mobile health applications, and if there a lot of times it is really asked, do you want your data to be used for further research? And there, for example, they have the free choice. It is really freely given consent if they give it, but a lot of people do not want that. And so you have to record that somewhere. And so for me, that is also labeling the data. So it is more than for me, it's a sort of extra layer, which is maybe simpler than what the data scientists are doing, but I think it is definitely worthwhile of taking it into consideration.
Okay, so I think Frank had to leave already, but I would like to thank both speakers. And Magali, I'd like to thank you very much for a very difficult topic, which you tried to bring it to the attendees in a very, let's say, easy way, if that's possible at all. But at least I think it's clear that we should not make a choice between privacy on the one hand and better healthcare on the other hand, that both can go together. So there were a few questions, so we have been answering them, or you have been answering them. For the attendees, I would like to tell you, don't forget, the 10th of June, we have 2 more speakers about health insurance. So one from Kaiser Permanente and one from CZ in the Netherlands. So thank you for being here, and I hope to see you the 10th of June. Have a good time. Thank you, Magali. Bye-bye.
Thank you. Thank you all. Thank you. Bye.